Assalamualaikum to Dr. Ruslawati and all my friends. My name is Nurin Jazleena binti Azman. My matrix number is 06DKA24F1092. So today I will presenting about hydrodynamics. So let's see what is hydrodynamics. Hydro is water, while dynamic is motion. Hydrodynamic is the branch of fluid mechanics that studies the motion of liquids and the forces acting on them. It focuses on how fluids, mainly water or other incompressible liquid, behave when they are in motion, whether in natural systems like rivers or ocean, or in engineered systems such as pipelines, pumps, and turbines. So, in a simple term, hydrodynamic explains how and why liquids move the way they do, and how engineers and scientists can use this knowledge in a real-world problem. So let's move to the next part, which is hydrodynamics concept. We have 4 points in this concept, which is first we have fluid properties, second we have governing equation, third we have fluid flow types, and Reynolds experiment is the last one. So let's move to the next part, which is fluid properties. In this part we have a lot of properties, but I will take 4 only, which is density, viscosity, pressure, and velocity. Let's move to the first one, which is density. Density is the mass per unit volume of a fluid. It also determines how heavy the fluid is and affects buoyancy, pressure, and flow behavior. Next, we have viscosity. Viscosity is a measure of a fluid's internal resistance to flow. It also said high viscosity equal to flow slowly, such as honey, and low viscosity equal to flow easily, such as, for example, is water. So let's move to the third one, which is pressure. Pressure is a force exerted by fluid per unit area, PA or Newton over meter square. The important in understanding fluid motion in pipes, pumps, and open channel. And lastly, we have velocity. Velocity is the speed and direction of fluid particles. It also essential in describing flow types such as laminar, turbulent, steady, and unsteady. Let's move to the next part, which is flow types in hydrodynamics. What flow we got from Reynolds experiment? We got a lot, but I will choose 4, which is first we have turbulent flow, second we have laminar flow, third we have unsteady flow, and lastly we have steady flow. So what formula of Reynolds number? The formula is RE equal to rho VD over micro, which is micro is stand for fluid dynamic viscosity in kilogram or meters per second. Rho we have fluid density in kilogram per meter cube. V we have fluid velocity in meter per second, and lastly D we have pipe diameter in meter. So what is Reynolds experiment? Reynolds experiment was carried out by Osborne Reynolds to study the nature of fluid flow. He wanted to find out when a fluid flows smoothly and when it becomes chaotic, which is turbulent. So let's move to the part which is I will explain about 2 types of flow, which is turbulent flow and laminar flow. So what is turbulent flow? Turbulent flow is a type of fluid motion where the fluid particles move in irregular, chaotic, and swirling patterns rather than in smooth orderly layers as in laminar flow. It usually happens at high Reynolds number. In pipe flow, typically RE more big 4000. So example of turbulent flow is first water through a large pipeline at high speed. When water flow rapidly in municipal water supply pipes, the motion is turbulent. Next, we have example is smoke from a chimney. Initially, smoke rises smoothly, laminar, but after some distance, it starts swirling and dispersing irregularly, which is turbulent. Next, we have laminar flow. So what is laminar flow? Laminar flow is a type of fluid motion where the fluid particles move in smooth, parallel layers with no mixing between adjacent layers. It occurs at low Reynolds numbers. In pipe flow, typically Re a little more slow is 2000. Example of laminar flow is lubricating oil in machinery. Oil film between moving surfaces usually experience laminar flow, which reduces wear and friction. And next we have blood flow in capillaries. In very small blood vessel, blood moves in laminar fashion due to low velocity and small diameter. Next, I will explain to you guys about governing equation. So this equation describes how fluids move and interact with force. We have two governing equations, which is we have continuity equation and Bernoulli's equation. First, what is continuity equation? The continuity equation is a fundamental principle in fluid mechanics that expresses the conservation of mass in a fluid system. It states that the mass of a fluid entering a controlled volume must equal the mass of fluid leaving it, provided there is no accumulation or loss of fluid inside the system. The continuity equation is written as A1 multiple V1 equal to A2 multiple V2. The continuity equation is written as A1 multiple to V1 equal to A2 multiple to V2. So where A equal to cross-sectional area of the flow, while V equal to velocity of the fluid at the section. What is Bernoulli equation? Bernoulli equation is a fundamental principle in fluid mechanics that comes from the law of conservation of energy. It states that the total energy in the fluid flow remains constant along a streamline, provided the flow is steady, incompressible, and frictionless. So the Bernoulli's equation is written as P plus 21 rho V2 plus rho GH equal to constant, where P is pressure energy, 1 over 2 rho V square is kinetic energy per unit volume, rho GH is potential energy per unit volume, rho is density of fluid, V is fluid velocity, G is gravitational acceleration, while H is elevation above reference point. Lastly, I will explain the case study hydrodynamics in civil engineering. I take numerical modeling on physical model of ringlet reservoir located at Cameron Highland, Pahang, Malaysia. Focus of case study is how storage capacity and structure like gradients affect flow velocity, water depth distribution under various written period flows using a physical model plus two-dimensional numerical model. The numerical model matched the physical experiment fairly well. Velocity and depth patterns change with flow conditions. Groins help in controlling sediment movement. For reservoir operation, sediment control, planning dam reservoir design, antiseptic change under fluid and dry condition. In summary, hydrodynamics in Malaysian civil engineering is not just called academic. It's crucial for designing dams, levees, drainage systems, reservoirs, and coastal defenses. By understanding how water moves, civil engineering can predict floods, manage sediment, reduce erosion, and protect infrastructure and communities. I think that's all from me. Thank you.